Alrighty, so I'm going to read this problem one more time for you to stamp important information. Please pay close attention to what the problem is asking us to find. Your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. All right, so they gave us a table. So we're going to continue using this as our draw portion of redraw right. And we're looking at the two things that we are comparing in this problem. So I underlined some information, but particularly in the table, we are comparing gallons and miles driven. So what is the problem asking us to find again? So I underlined that statement saying that it wants us to find out if our mother can make it to the next gas station with the amount of gallons she has now. Okay, I did highlight that the nearest gas station is 26 miles away. So that's how far we need to be able to get. So I want to make sure we keep that in mind as we begin solving. So first, looking at the values in the table, I don't see a number of miles that matches with the half gallon she has in her tank. So I can add half gallon here because it's not actually in our table. And so that was not pretty. So I'm just going to show that it's missing. And we're actually going to incorporate some more values here in a bit. But what could we do to get to that half gallon? Well, we could determine how many miles she can drive on half of a gallon once we find out how much 1 gallon is, right? We could first find out how many miles she can go with 1 gallon. Well, what is that called if I find the miles per gallon, right? I'm not saying per 10 gallons, per 5 gallons, per 7 gallons, right? So when we see that per, each, or every, we know that there is an invisible 1 here, right, for 1 gallon. And what was that vocab word called? The unit rate. All right, we've been using that pretty regularly, but I know that we learned a new vocabulary word in the last lesson. And what was that? It was super lengthy, right? It was the constant of proportionality, right? The number that makes tables, graphs, relationships proportional because it changes at a constant rate. Awesome. Well, we know how to do that. We know that we need to divide the y over the x, right? So y over x to find, I remember there was another variable that we used. What was the variable we used to represent constant of proportionality? That's right. It was k. Remember that funny letter that's not actually in the term, but yet we use that to represent constant of proportionality. All right, so we have our setup. So now that we have reviewed our terms from the last lesson, let's go ahead and pick a pair of numbers in our table to find k. So I could pick any of them, and I'll choose 4 and 112. I'm going to choose this row. But I don't see y and x on my table. So how am I going to figure out which one's the y and which one's the x? Well, usually I know y is on the right side and x is on the left side, but I know that's not going to be always, right? Sometimes we get tricked, and sometimes they actually will place the y here and the x here, so we know we need to look very carefully. But let's think about this. Do the miles driven depend on the gallons of gas that we drive? Or does the gallons of gas that we drive depend on the miles driven? So if we're finding miles per gallon, that is telling me that the miles depend on how many gallons of gas we have, right? If we don't have any gas in our car, we're not driving anywhere. So we know that y depends on x. So the miles is y and the gallons are x. Great. So now that I have that, I can set this up because my y value is 112 and my x value is 4. So we're going to break up 112 miles, dividing them into 4 gallons, right? So I know that this is 1 gallon, 2 gallons, 3 gallons, 4 gallons, and it gives me a total of 112 miles. And so that's just a reminder that I am dividing the 112 into 4 pieces, or into the 4 gallons. And so we're putting our seats here. I know 4 goes into 1 0 times, 4 goes into 8 times, Bring down the 2. 4 goes into 32. 8. All right, so we get 28. So I know this gallon of gas can go 28 miles, and so can this one, and so can this one. So in other words, we can go 28 miles per gallon. So for every 1 gallon. Awesome. So I know I could have chosen the other 2 values, but I wanted to choose this one. So how can we check that she is traveling at a constant rate? So we can use this unit rate or this constant of proportionality that we found. So let me go ahead and COP instead of writing the whole thing to check the other values in the table. So I could keep dividing all of them up, right? I could divide 224 divided by 8 or 10 divided by 280 divided by 10. But I actually prefer to go a different direction. So if 112 divided by 4, if 112 divided by 28, we would get 4. So I know that if we go in this direction, 4 times 28 will get us 112. So I'm going to take that same idea and I'm going to do that to the other 2 to check our work. And so I'm going to multiply 10 times 28 and 8 times 28 to check and see if these values also have that same constant of proportionality. And sure enough, we get 224, and 28 times 10 is 280. So sure enough, they also all match. So what did we just find? Well, we know the constant of proportionality is 28, and then we also said that it means that she can drive 28 miles on 1 gallon, right? So that's going to be important to be able to describe what the constant of proportionality means given our context. So if that is her rate, then how can we write a rule or an equation so no matter how many gallons of gas she has, we can find out how many miles she can drive? Well, I know that X represents the gallons and the Y represents the miles driven because, again, the miles driven represents the gallons of gas she has in her car, right? So we have the Y and X labeled. So what did we do with the gallons to get the miles again? We multiplied by 28. Great. So to get Y, so let me write part of this out. To get Y, we should multiply. In fact, let me use a different color so it kind of pops out. We got to multiply 28 times X. So if I was going to write that as a multiplication, as an equation, right, showing multiplication, then we would write this as Y equals 28x, right? We don't need to show the multiplication sign because when they are smushed together like that, that is showing multiplication. So now we have our rule, right? So this is our fancy equation showing exactly what we can do to find the actual answer to our question because we're not there yet. So how can we find out how many miles she drives on half a gallon? Well, gallons represent X, right? So I know that she is only driving, or she only has half a gallon in her tank, and we can multiply that by 28 to get Y, to get the miles driven, which is the whole point of our problem here. So I'm going to think of half of 28. If we just have a quick review of multiplying fractions, I know that I multiply straight across. And I know that it's 28 over 2 is seeing how many times 2 goes into 28. We got a lengthy problem today, and 2 goes into 8 4 times. And so 1/2 of 28 is 14. So what did we just get? What does Y represent again? It definitely represents the miles. So then she can drive 14 miles. Let's use a different color, right? We want to keep things nice and neat. Rainbow, because this is our sentence. She can drive 14 miles on half of a gallon of gas. Okay, but that's still not the end because the nearest gas station is actually 26 miles away. So can she make it? Nope, she cannot. So this is like one part of our problem. And the second is no, she can't make it to the nearest gas station. They're going to have to find a tow truck or call someone to help. But we know she won't be able to make it because she only has 14 miles left in that half gallon in her tank. Perfect. Thanks for sticking with me.